Hi everyone, welcome to the lesson on listing outcomes. So again, it's a topic in probability where we look at systematically listing the outcomes of two events or one event happening. Okay, so looking at the knowledge organizer for this topic, so we're given some keywords and their definitions and few examples. You can always refer back to this organizer, knowledge organizer, if you do not understand a certain word that I might use, and it's got all the key information on this. And the second page of this, we got a few more definitions and keywords. And today we're looking at the sample space diagrams, so listing outcomes in a systematic way. Okay, so let's start with a fairly simple example. It says a fair six-sided dice is rolled and list all the possible outcomes and how many outcomes are there. Okay, so a dice has 6 sides, okay, and it has the numbers 1, 2, 3, 4, 5 and 6 on each side, and list all the possible outcomes. So that is 1, 2, 3, 4, 5 and 6. So we can write that down. Okay, and then it says how many outcomes are there in altogether? There are 6 outcomes. And it says, part B says, are the outcomes equally likely? Yes, because each number appears only once, so every number has an equal chance of appearing. So yes to this one. Okay, and then part C says, work out the probability of 5 or a 6. Now when you got something written like this, P on the outside and 5 or 6, that means this is the probability. Okay, so what's the probability of 5 or a 6? Well, 5 or a 6, there are 2 options out of 6. So that would be 2 out of 6, which is a third. Now you can leave the fraction in probability as 2 over 6. You don't have to cancel that down. But if you like to cancel it down, it will be 1/3. Okay, the next part is the probability of an odd number. Okay, so there are 3 odd numbers on the dice. So part 1 and part 2. So there are 3 odd numbers. So that's 3 out of 6, which is a half. And then a prime number. So what is a prime number? So a prime number has only 2 factors, 1 and itself. For example, 2 is a prime number. 1 times by 2 will only make 2. 3 is a prime number. Only 1 times 3 will make a 3. So it only has 2 factors, number 1 and the number itself. And 5 is another prime number because only 1 times by 5 will make a 5. Now 1 is not a prime number because it only has 1 as a factor. Okay, so there are 3 prime numbers on there, which is we got 2, we got 3 and we have 5. So that's 3 out of 6 again is a half. Okay, next question, it says 2 fair coins are flipped and draw a 2-way table to show the possible outcomes. So 2 fair coins. Now fair means there's nothing wrong with a coin, they're not biased. So head or a tail have equal chance of appearing. So 2-way table they want you to complete for part A, and they're given you a 2-way table, the diagram of that. So coin 1 and coin 2. So you could have, to answer the first question, you could have head or a head. You could have head or a tail. So you could have a tail on the first coin and you can get a head on the next one. Or you could have tail on both coins. So that is a two-way table for part A. And B says how many possible outcomes are there. So possible outcomes, we got 4 because head and a head and a tail or a head, or tail and a tail. So there are 4 outcomes possible. And part C says write the probability of getting 2 heads. Okay, now 2 heads appears once out of 4. So there are 4 options altogether, and so it's 1 out of 4. Okay, part D, it says write the probability of getting 1 head and 1 tail. Okay, so 1 head and 1 tail. Just gonna get rid of this, sorry. So that was head and a head. So 1 head and 1 tail appears there, and it appears there. So it's a 2 out of 4, which is a half. Okay, and part E, it says write the probability of getting at least 1 head. Okay, now at least 1 head, that means we could have 2 heads. That's at least 1 head. And then we got 3 options, head or tail, and tail or a head. So we got 3 options there. So 3 out of 4. Okay, the discussion part says, how can you use the probability of no heads to work out the probability at least 1 head? Okay, no heads mean they both have to be tail and tail. So tail and tail, the probability of that would be 1 out of 4. So that means to have at least 1 head, it would be 1 take away a quarter, which is 3 quarters. So same answer, but in a slightly different way. Okay, so in this question, it says 2 spinners are spun, and copy and complete the two-way table showing the possible outcomes. Okay, so 1 spinner has 4 options, red, green, blue, and yellow, and we can list them down at the top. And the second spinner on this side, we only have blue, green, and red. Okay, so we can start with, so we can have red on the first spinner and red on the next one. We could have red on the first one, we could have green on the next one. So next one we can fill in, it will be red and it will be blue. And then red and yellow. And we've got green and red, we will have green and green here, and green and blue, and green and yellow. So complete this, and then come back and check your answer, please. Okay, so this is what you should have got, completing the table. Now, one thing to notice is how many options are there. Okay, if you count them, we've got 3, 6, 9, 12. There are 12 options all together, okay? But you can work this out. There are 4 options on this spinner, and there are 3 options on this spinner, and 3 times by 4 makes 12 also, okay? Or you can actually individually count how many these options are there, okay? And okay, so it's a work out the probability of red and a red, okay? So red and a red appears here, so that's 1 out of 12. And then it says work out the probability of at least 1 green, okay? So this is where you have to be careful now. You got to circle everything with at least 1 green in there. So that's 1 there. So 2, 3, 4, 5, 6. Okay, so I hope I haven't missed anything out. So there are 6 options out of 12 with the green. Okay, and the next one, it says work out the probability there are 2 yellows. Okay, so if you look at the diagram, we can't have 2 yellows because this spinner does not have any yellow on that. So we can only ever have 1 yellow. So that will be 0. Okay, so let's try this exam question. It says Isha spins a fair 5-sided spinner, and then she throws a fair coin, and list all the possible outcomes she should get. The first one has been done for you, so you could have 1 or a head. And then the part B says Isha spins a spinner once and throw the coin once and work out the probability that she will get a 1 and a head. Okay, so if you want to pause the video, have a go, and then check your answer. Okay, so you should have got something like this, a sample space diagram. So we got the spinner, the options on there on one side, and then we got a head and a tail for the coin at the top, and then we fill in all the possible outcomes. Okay, so that's 2 marks for part A. Then the part B, it says Isha spins the spinner once and throw the coin once, work out the probability that she will get 1 and a head. Okay, so 1 and a head appears only once, and there are 10 options altogether. The reason why there are 10 options, because there are 2 options for the coin and 5 for the spinner, and 5 times by 2, that gives you 10, or you can just count from individually from the table. So this 1 out of 10. Okay, next question, it says a fair dice is numbered 2, 4, 6, 8, 10 and 12, and another fair dice is numbered 1, 3, 5, 7, 9 and 11, and the dice are rolled together and the scores are added. It says copy and complete the sample space diagram showing the possible total scores, and then answer these questions. Find the probability of scoring a total of 7, more than 12, an even number, a multiple of 3, and part C is which is more likely, scoring a multiple of 3 or a total of 7. So pause this video, have a go at this question, and then check your answers. Okay, so firstly we list all the options down on one side for dice 1 and for dice 2 on this side, and we start adding the numbers together. So 2 plus 1 make a 3, and 4 plus 1 make a 5, and 6 plus 1 7, 8 plus 1 9, 10 plus 1 11, and so on. So we have 12 plus 1, which is 13, and then you go to the next row. 2 plus 3 is 5. So fill this table in. Okay, so you get something like that. So basically adding the numbers on both sides together. Okay, and so that's part A done. And part B was find the probability of scoring a total of 7. Okay, so how many 7s do we have? So there is a 7 over here. Okay, and I can't see any of this. Well, actually there's one more over here. So there are 2 7s anymore. Nope, so there are 2 7s. And how many options are all together? Well, we had 1, 2, 3, 4, 5, 6 options on one side, outcomes, and we had 1, 2, 3, well, it's a dice 6-sided really, so 6 times 6, there should be 36 outcomes altogether, and there are 2 7s. To get a score of 7, the probability of that would be 2 out of 36. Okay, now part 2 of this question, more than 12. Okay, so now have a look at how many numbers are more than 12, and if, well, we can start from here. We got this number here, so let's just get rid of that and highlight instead. Okay, so we got more than 12 are these numbers, so highlight them, all of them. So all this section over here, we got more than 12. Okay, so highlight all of them and count them, how many there are. Okay, so there are 21 numbers out of 36 which are more than 12. Okay, now then it says what's the probability of an even number? So look again in that sample space diagram and look at all the even numbers and count how many there are. Okay, so there are only 2 even numbers. So the probability of scoring an even number would be 2 out of 36, and then part 4 a multiple of 3. So again, look for a multiple of 3 and highlight those and count them. Okay, so I've highlighted multiples of 3 in yellow. Let's count them. So got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 out of 36 which are multiples of 3. And then part C, it says which is more likely, scoring a multiple of 3 or a total of 7. Okay, so the total of 7 is 2 out of 36. Okay, and scoring a multiple of 3 is 11 out of 36. So this is a bigger fraction. So that means this is more likely in this question. Okay, so more likely. Okay, so that is a complete question. Okay, it says a bag contains 2 10p coins and 2 20p coins, and another bag contains 1 10p coin and 3 20p coins, and Olivia takes 1 coin from each bag, and what is the probability of getting 40p? Now, what's going to help you with this question is drawing the sample space diagram and listing the outcomes. So have a go at this question and then check your answer. Okay, so a sample space diagram would look something like this. And so one bag contains 2 10p's and 2 20p's, and the other bag contain 1 10p coin and 3 20 pence coin. And when you take 1 coin each from each bag, and what's the total of scoring, what's the probability of scoring 40 pence? Okay, so what I've done is I've just added 10p and 10p, and then 20 and 10, which is 30, and so on. Now, if you look here, how many options there are altogether? We have 1, 2, 3, 4 coins in one bag, and then we got 4 coins in the other bag. So there are 16 total outcomes that could happen. And how many of them were 40 pence? So 1, 2, 3, 4, 5, and 6. So the probability of getting 40p would be 6 out of 16.